we have the functions f of x, which is a square root graph, and g of x, which is a parabola, and we want to determine an explicit equation for g of f of x in A. So, first of all, f of x is the square root of x. That gets plugged in to g. And then the square root gets plugged in, f of x, now that square root gets plugged into g, so we would have the square root of x squared minus 4. And what happens when you square a square root? It cancels out, and you just get x minus 4. Now, they had this question on a final exam, maybe about, I don't know, either 2 years ago or like 6 years ago. Because there's like this time in between where there's COVID. So it was either like right before COVID or right after COVID. And they asked students to graph the answer. So when they look at your answer, does it make sense that you would think, hey, that's a straight line? That's not a very hard question. And so students went and they said, my y-intercept is minus 4, and my slope is 1. And they graphed the following answer and got 0 out of 1. It was really harsh. They didn't give them any marks for their graph. That is the right line. I didn't make a mistake in drafting a line. But the problem is with the domain. Now, when you look at your final answer, you would say your domain is everything if you just looked at your final answer. But what we have to consider with the composition of functions, and we can show it with the machines, like what's happened here is you had two machines, right? You first put stuff into f, and then you put stuff into g. And the rule for f is f was the square root of x, and the rule for g was whatever you put in, you square, and you minus 4. Can you see if this was in your garage, and you threw a negative number into that first one, that first machine would blow up, right? We have issues right here already that machine 1 would blow up if you threw in any negative number. So even though your answer is x minus 4 in the end, which appears to have no restrictions, because of what happened earlier, we have to add a common here and say that x has to be bigger than or equal to 0, and on our graph, that would mean that this part of our graph has to be missing. And this would be the final answer of the graph. Really small detail. You see how it's super easy to be caught on that on the exam, because you get to your final answer and you go, oh, that's a straight line. I can do this. No problem. With composition of functions, we have to be careful with the domain because it's going through two machines. We replace it with a new equation, but that new equation still has that restriction because before anything can happen, that square root is still part of your equation. So it's different than just having an x minus 4. That's a whole line that has a domain of everything. But because it had to go first through the square root graph, we weren't allowed to put any negatives in it. So it's something to be careful with. Okay? Then for B, now we're doing f of g of x, and g of x was x squared minus 4. And then f of x says whatever you put in, we square root it, so we would square root x squared minus 4. And this connects to what we did at the beginning of class yesterday with the getting started. Okay? I mean, sometimes it's not bad to think about the two machines going in a row. This time, first it's going through g, which is x squared minus 4, and then it's getting square rooted in f afterwards. Because the g function is first, it's inside. Can you see it? The domain at the start is everything. There's no problems there. But then if a negative number comes out of G, we're going to have a problem when it goes into the square root. So we do have to find our domain here, and this is where that idea at the beginning of this lesson comes into play, right? No problems at the beginning, right? I can even put here, no problem. Problem. Here we have our problem with our domain. Why? Because not everything is going to work. What do we need? We need the inside to be bigger than or equal to 0. And this is that inequality solving that we did at the beginning of yesterday. How do we solve inequalities? First of all, you make it equal to 0. Make a number line. And since it's greater than or equal, we fill in these circles to include them. And then we check where things are true and where things are false. If I plug in 0, is minus 4 greater than 0? That is false. If I plug in 3, it's true. If I plug negative 3 squared will still be positive 9. That's true as well. So we would say that our domain, and you can either write it like this, x is less than or equal to 2, negative 2, or x is bigger than or equal to 2. And you can write it from negative infinity to negative 2, square bracket including, and then starting again at 2 and going to infinity. So it asked us to find the explicit equation, right? Here is the explicit equation for this one. And here was the explicit equation for this one. Sometimes you might even want to put a box around this whole thing, because sometimes they say you should include the restricted domain in your explicit equation. I felt that when you're doing the exams, maybe one of you will come across this question when you're doing your practice exams. You're like, oh, I remember Mr. Jerry was talking about this one. And I felt like it wasn't really set up to help students not fall into the mistake of losing the mark. You know, sometimes you can, I can make a question where I sort of help you realize something. I could have first asked, what's the domain? And if you screw that up and then screw up the graph, well, you deserve to lose the mark.
Right? You're a screw up.
Yeah, it's like well, what a coincidence. Hey, I'm recording.
What are you doing?
Oh my goodness. That's awesome. All right, questions for practice on this one are 6 and 10.